What if I told you there's a colossal structure that begins at the very edge of our solar system, a vast, unseen shell that surrounds our sun and every planet, yet we've never directly observed it? It's made up of ancient, icy fragments, billions or even trillions of them, each the size of mountains, and it may mark the true boundary of our solar system. Far beyond the reach of even our most powerful telescopes lies the Oort Cloud, a mysterious region where the Sun's influence begins to fade, giving way to the infinite void of interstellar space. But what exactly is the Oort Cloud if we've never seen it? How do we know it's real, and why do some scientists even question its existence? Let us dive into this fascinating mystery. I'm Alex McColligan, and you're watching Astrum. Join me as we travel to the farthest edge of our solar system and beyond to explore one of astronomy's greatest enigmas. You've probably heard of the asteroid belt and maybe the Kuiper belt. Both are rings of debris, one between Mars and Jupiter, the other just beyond Neptune. These regions orbit in the same direction and on roughly the same plane as the planets. The asteroid belt contains millions of rocky fragments. The Kuiper belt, first proposed by Gerard Kuiper, is a field of icy bodies and dwarf planets that begins at Neptune's orbit and stretches outward. It's the birthplace of short-period comets, those with orbits of less than 200 years. Sometimes, gravitational interactions push a piece of Kuiper belt debris into the inner solar system, where it becomes one of these comets. But what about long-period comets? These aren't as predictable. Their orbits can span tens of thousands or even millions of years. They appear to come from all directions, not just from the plane of the solar system. This led Dutch astronomer Jan Oort to a profound hypothesis in 1950. He suggested that these comets must originate from a distant, spherical shell of icy debris that surrounds the solar system, what we now call the Oort Cloud. Let us break it down. Unlike short-period comets, which originate in the Kuiper belt, long-period comets appear to follow orbits that suggest they originate from about 50,000 astronomical units from the Sun. For scale, 1 is the distance from Earth to the Sun, about 150 million kilometers. That means these comets come from a region roughly 7.5 trillion kilometers away. To compare, Neptune, the farthest planet, is about 30 from the Sun. The Kuiper belt extends from about 30 to 50 The scattered disk, a more distant extension of the Kuiper belt, might reach out to 1000 But long-period comets, their orbits suggest they're coming from way farther out, possibly 100,000 or about 1.5 light-years away. So how did this Oort cloud form? Astronomers believe it began with the leftover debris from the formation of the planets over 4.6 billion years ago. As the gas giants grew, their gravity flung surrounding planetesimals outward. Some were ejected into interstellar space, but many settled into elongated orbits, forming a distant, spherical cloud held loosely by the Sun's gravity. Over time, gravitational nudges from passing stars, molecular clouds, or even the Milky Way's tidal forces could disturb these icy bodies, sending some of them hurtling inward as long-period comets. In fact, about 70,000 years ago, a binary system called Scholz's star passed close to the outer edge of our solar system, possibly disturbing parts of the Oort cloud. Modern models suggest the Oort cloud might actually have two regions, an inner disk-like region, somewhat similar in shape to the Kuiper belt, and an outer spherical shell, which defines the classic image of the Oort cloud. Altogether, the Oort cloud could extend from around 2000 to as far as 100,000 or 1.5 light-years. It may even overlap with the hypothetical Oort clouds of other stars. Now consider this: the Voyager 2 spacecraft, launched in 1977, is traveling at about 56,000 kilometers per hour. After nearly 50 years, it's reached 139, still barely scratching the surface. It would take another 300 years just to reach the inner edge of the Oort cloud, and up to 30,000 years to cross it entirely. So why can't we see it? The answer is light and distance. Unlike stars and galaxies, Oort cloud debris doesn't emit its own light. And unlike planets or asteroids, it's too far to reflect much sunlight. Imagine trying to spot a mountain-sized object from 450 billion kilometers away. It's like finding a grain of sand from across the ocean. Still, most astronomers are confident the Oort cloud exists. We see its fingerprints, the orbits of long-period comets, clustered distances, and directions from which they arrive. The evidence is circumstantial but compelling. And remember, many landmark scientific theories began as indirect observations. Copernicus and Galileo proposed the heliocentric model not because they could see the planets orbiting the Sun, but because the data pointed that way. The Oort cloud may be invisible for now, but the science behind it is solid. And who knows, in another 100 years, we might finally find a way to see it, or we might discover something entirely new. Until then, the Oort cloud remains one of the greatest mysteries in modern astronomy. Please like, share and subscribe my channel. Thanks.